All right, let's dive deep into your car and follow the path of a single, powerful command. We're going to trace the journey from your foot hitting the brake pedal all the way to the wheels, and we're going to see how that one simple move can stop thousands of pounds of metal in its tracks. Let's get into it.
Really think about that for a second. You're cruising along in a machine that weighs a couple of tons, moving at highway speeds. How in the world does one simple push of a pedal bring all that momentum to a safe, controlled stop? It feels like it should be impossible, but it's actually just a brilliant journey of force amplification. And that journey, that whole incredible chain reaction, it starts in the most basic way you can imagine, with your foot on a pedal. Now this thing isn't just some simple on-off button. The brake pedal itself is actually a super clever piece of engineering. It's a lever. Just like using a crowbar to lift something heavy, a lever multiplies your effort. The brake pedal does the exact same thing for your foot, giving your push an initial boost before it even goes anywhere else. But that little boost from the pedal, that's just the warm-up act. The next stage is where things get really, really powerful. We're leaving simple mechanics behind and entering the world of hydraulics, where that force gets magnified like you wouldn't believe.
So here's where the force completely changes its form. First, that push from the pedal gets received. Then, it hits the brake booster. This is the secret weapon that makes braking feel so easy. It uses engine vacuum to multiply your effort like crazy. Finally, all that amplified mechanical force arrives at the master cylinder, and this is the magic moment, where a physical push gets turned into powerful hydraulic pressure. And that is exactly why the master cylinder is often called the heart of the system. It's the perfect analogy. Just like your heart pumps blood, the master cylinder takes that force and starts pumping brake fluid under intense pressure out to the rest of the car. We've officially gone from a physical push to a powerful liquid force. Okay, so that brings up the obvious next question, right? We've created all this hydraulic power up near the engine, but how does it travel all the way to the wheels, which are way back there and are constantly bouncing up and down? Well, that pressure travels through a network that acts, you guessed it, just like our body's circulatory system. You can think of it as a set of arteries, all designed to deliver that pressure exactly where it needs to go without missing a beat. This delivery network has two main parts. First, you've got these rigid steel brake lines. They're like the main highways that run along the car's frame. But since your wheels have to turn and move with the suspension, you also have these flexible, super strong rubber hoses that make the final connection. They're the crucial link that lets the pressure get delivered no matter how bumpy the road is.
All right, the journey is almost over. That hydraulic pressure born in the master cylinder and sent flying through the lines and hoses has finally arrived at its destination, the wheels. This is where it all comes together. It's time to turn all that pressure back into stopping power.
And there are two main ways this happens. Let's start with the most common system you see today, especially on the front wheels, the disc brake. And its method is all about a powerful, effective squeeze. The main player here is the brake rotor. It's a big, heavy metal disc that's bolted right onto your wheel. Wherever the wheel goes, the rotor goes, spinning at the exact same speed. This is our target. And the tools we use to stop that spinning rotor, those are the brake pads. These are just blocks of super high-friction material made to handle insane amounts of heat and pressure. Their one and only job is to clamp down and create friction.
And the component that makes it all happen is the brake caliper. This is where we see the final transformation. The caliper gets that hydraulic pressure we've been following all this time, uses it to push out some pistons, and squeezes those brake pads against both sides of that spinning rotor, and that brings your car to a stop.
But that's not the only game in town. The other common system, which you'll often find on the rear wheels, is the drum brake. Now, instead of squeezing from the outside, this one uses a powerful push from the inside. So in this system, the big rotating part is the brake drum. And just like the name says, it's a hollow metal drum that's attached to the wheel and spins right along with it.
Instead of pads on the outside, drum brakes have what are called brake shoes on the inside. They're these curved pieces with friction material that sit just inside the drum's surface, waiting for the signal to go.
And the activator here is the wheel's cylinder. It takes in that same hydraulic pressure, but instead of squeezing, it uses that pressure to push the brake shoes outward, forcing them hard against the inner wall of the spinning drum. That friction is what stops the car.
So there you have it, squeeze versus push. Two brilliant solutions for the exact same problem. Disc brakes squeeze inward.
They're awesome at getting rid of heat, which is why they're almost always up front where most of the work happens. Drum brakes push outward. They're a bit simpler and cheaper, which makes them a good choice for the rear wheels. Both turn that hydraulic pressure into friction, just in totally opposite ways.
This little table really breaks it down for us perfectly. In a disc system, you've got the caliper acting on the pads to grab the rotor. In a drum system, you have the wheel cylinder acting on the shoes to stop the drum. Two different teams, same exact goal. And that's the whole trip. It starts with the simple leverage of a pedal, gets a massive boost, gets turned into hydraulic power, travels through the car's arteries, and is finally translated back into a physical force that stops you safely. It's a pretty incredible system when you think about it.
So I'll leave you with this. The next time you're driving and you gently press that pedal, take a second. Will you picture the calipers squeezing down on the rotors or the shoes pushing out against the drums? Pretty cool to know the incredible journey of force that's happening right under your foot.